Okay, so today actually guys we will able to discuss about the GBSA calculation after the MD simulation and how actually we'll be calculate the GBSA. So let's get started off. So in this case we'll need some sort of the scripts that will actually we need to run this energy calculation. Okay, so in this case we need the scripting. So first of all, we are in a trial 3. Okay. Oh, so which is the actually where we are right now in the DMBC. We are actually analyze the DMBC. So in the trial 3, I will able to load this script which is necessary for this uh, energy free binding energy calculation. So let's upload. Okay. So where is this uploaded? Uh, I have uploaded in the wrong directory, so let's upload it again. Okay, so here I can upload these files. It will take some time. Yeah, to make sure in the terminal you're in the right directory. So you can copy here and go cd and paste here. So you're right now in the correct directory. So you can run you are actually using the Amber module. So right, I'm load module load Amber. Yep. So in this case, actually, before to run this, let's discuss about what actually the GBSA or which is called the generalized bound surface area. So let's go. Okay, maybe here we can discuss a little bit about. So in my case, actually, I have run the simulation. My receptor was in the beta cyclodextrin and the compound is the BBM, bromobenzyl methoxylum, which is a drug or ligand, whatever you can say that. So in a GBSA, I will calculate GBSA after post-docking state. I mean, after MD simulation, then you can analyze or interpret this free binding energy. So how actually will be calculate the GBSA? So we need the trajectory from the results of the MD simulation, and you also need, so we are going to calculate the free energy binding, so that's why we will be implement or consider this equation for analyze the binding energy. So here delta G binding we are going to find, so that's why we'll need to delta G complex. So you will have to abstract from the delta G ligand and plus the delta G receptor. So you will have to remember this equation before to go analyze this. And okay, so let's try to understand what the meanings of this equation. The meaning of this equation actually pretty simple because of delta G complex. That means the free energy of a bound system between ligand and the receptor. So in a bound system, the actual free energy, the receptor, that means in my case beta cyclodextrin, and the ligand BBM. So the summation of this energy into a solvent system that will represent the delta G complex. And delta G ligand, which will represent the free energy, just only along ligand, okay, not the receptor. So delta G ligand, which will represent only the ligand free energy into a solvent environment. And delta G receptor, that means the receptor, uh, the individual receptor, that means in a beta cyclodextrin isolated environment in a solvent. So what kind of the energy or uh, it represents in this case, which will be delta G receptor. So this kind of equation we'll have to understand. So if we want to actually calculate the delta G binding energy, then we need the delta G complex, the holistic, the interaction of uh, ligand and complex, so we can abstract it from individual. Okay, so let's go to the terminal and to run again. So we are in a directory, right? So now we can, first of all, we'll have to run these script. So which script for initially we'll have to run on this job script. So this job script actually, so we can copy here from it. Yeah. So after copy here, you also check off your input file because of you can see clearly this is the trajectory files. So I have considered about the 200 to 500 nanoseconds of my simulation, so which is the ANSI file of AMP. So, and we also, as a reference, we need the restart file, as well as in the script I have used in water, chloride, sodium, and we'll be able to generate the MD card file also as a trajectory output. So here is the actual script, you can use it. So okay, let's go again in the terminal. So I will able to run this script. So you need, I am right now here in the job. So to run this script, okay, so it will take some time to generate this script, so you can refresh it here. Okay, so it will take time. If it's not generating, you can also uh, try again to check of is it script, is this your script is right or not. You can check here, yeah, is it okay, or you can check it here, this job file. Yeah, here is the topology and here is up output, so you'll have to wait. Our goal is to generate this MD card. Yeah, it's running right now. Yeah, look at this, it's running. But interestingly, it's not generating the MD card file here. So we can actually find out the reason why it's not generating. So we're in the trial 3, right? So let's check out about the directory. Is this the same directory we have run or not? Yeah, actually maybe we can try again. maybe we'll have to go to the directory again. So that's how actually we can go to. So here again here. So here we was in the directory trial 3 analysis energy. Here we were. So we can actually copy here. We can try again, no problem. Oh, I think so. It's showing the too many arguments. So let's check what is the wrong of it. Mm, too many argument. Maybe you're giving a space in particular. Yes, I think it's a space. So that's why actually it's not taking this input. Okay, so we can actually, yes, no, it's okay. So now you can go to this right directory. Yeah, okay. And here, because of you are going to run this, so you can copy here. Yeah, yeah, it's empty card is now generating because of just one space actually that actually makes these things. So now actually app code is generating, so it will take some time. So we'll have to wait for a bit. Yeah, finally it's running, and we got this empty code file also. So now in this case, what can we do? So we have run. Now we'll be run another script. We can also able to run. So let's try to run this other script and to generate this the holistic information about it. Yeah, you can copy the directory easily, and here we are in the right directory. And now we'll able to run this input file. Okay, so go here. uh, you don't need to change of your this sometime in case your receptor mask, you can give the input as your uh, based on of your receptor. In case of the DNBCD, I have used 1 to 20, but in case of the BCD only, just the receptor, maybe it would be 1 to 8 or something like that. So you can change accordingly of your receptor. And here is the ligand. Okay, so script is ready. Now I will have to run this parameter. So go to here. You can actually run this one. Okay, first I will have to run this one. So go and yeah, it's creating. It's already created. I mean, 3 uh, parameter file already created. Okay, so we'll have to run the second one. Okay, so let's get to run in the second one. So here is the second one. You can run this one also. Yeah, it's also created. So here is the 4 different parameter file already we have created. This. Okay. Now what we'll have to do that the final script will have to run. This is the main script which will be a generate the holistic GBSA file. So go again the directory and paste here. Go and run. Yeah, it's working. So can you refresh it? Yes. Refresh. Look at this. All the necessary file and parameter is generated. So you can use this file for your calculation or analysis of GBSA. Yes. So we have finished of our the analysis, right? So that's how actually we'll able to run this script and to generate this energy parameter specifically in PBSA or GBSA, right? So the value actually generating this. Okay, thank you.